Debunking off-road suspension. Look carefully at these suspensions. There is something in common between these two. Did you see it? If not, you can go back and watch it again. Let's debunk this suspension. First, let's start with a 50 stiffness spring. Then we will add some weight to the top of the spring. We will call this weight sprung mass. This green block will represent unsprung mass. Let's make some suspension geometry, shall we? I've attached this same 50 stiffness spring onto a swing arm. Think of the swing arm and tire as unsprung mass. So that means there is no sprung mass. So in turn, all of the spring's energy is used to push the swing arm and tire into the ground. Here I have added sprung mass. Think of sprung mass as the vehicle's chassis, sitting on top of the suspension components. Now the spring is fighting the sprung mass and the unsprung mass. So most of the energy of the spring is used to suspend the sprung mass. This may cause the chassis to sag down to the ground. This means that the suspension is too soft, which also means the spring can't cycle the axle and tire. So we need to stiffen the spring. So let's use a 100 stiffness spring. Now there's more energy to cycle the axle and tire. This means we can compress and decompress the spring much faster, which means we can drive faster over off-road terrain while maintaining stability. This is called SI-KIO frequency. Let's take a look at suspension geometry. This green block represents the vehicle's center of gravity. I have added a rod to show the suspension pivot. Notice how the rod points up and behind the green block. This tends to make the suspension unsmooth. I've added weight to the rear of the vehicle to shift the CG backward. Notice how the rod is now pointing below and in front of the green block. This geometry seems to make the vehicle float over big bumps. This is better explained by the YouTube channel, Animagros.
Classic 4x4 shows how this looks with a more standard rear axle setup, where the driving force remains behind the center of gravity and tends to pull things upward for a bouncy ride. Keeping that center of gravity behind the line of force is why you'll often see lots of weight hanging off the back of desert race vehicles. Things like spare tires, tools, and so on.
You come on.